Hi guys, welcome to the channel. So in this particular video we are going to discuss some of the important terms which we are going to use in the spectroscopy. So the first term is wavelength. It is represented by symbol lambda. Now wavelength will be distance between two adjacent crests or troughs. Now what are these crests and troughs? So suppose this is a wave. This upper tip and this upper tip, these will be the crests, and these lower tips will be troughs T1 and T2. So the distance between these two adjacent crests or these two adjacent troughs, that will be lambda, or what we call as the wavelength. So if we talk about the units, then units are angstrom, centimeter or millimicron. Now 1 angstrom equals to 10 raised to power minus 8 centimeter, or you can say 10 raised to power minus 10 meter. Also 1 millimicron equals to 10 raised to power minus 7 centimeters. So this is about wavelength. Now moving on to the second term, that is wave number. This is represented by this symbol nu bar. So wave number is total number of waves which can pass through space of 1 centimeter. So it is reciprocal of wavelength, that is nu bar equals to 1 by lambda. This is the formula, and it is majorly used in IR spectroscopy. Now moving on to the third term, that is frequency. It is the number of waves which can pass through a point in 1 second. It is represented by nu, and nu will be inversely proportional to wavelength. So this is the frequency. Now moving on to the fourth term. So the fourth term is energy. Energy of a wave of any particular radiation can be calculated by applying the relation E is equals to h nu, where nu is equals to c by lambda. c by lambda. So E is equals to hc by lambda, where c is velocity of electromagnetic radiation, lambda is wavelength in centimeters, nu is frequency in cycle per second, and h is Planck's constant, and the value is 6.626 into 10 raised to power minus 27 erg second. This is all about the energy. Now we will discuss briefly about the EM spectrum or the electromagnetic spectrum. Now EM spectrum is arrangement of all types of electromagnetic radiation in order of their increasing wavelength or decreasing frequencies. So if we talk about the overall spectrum, then it is composed of cosmic rays, gamma rays, X-rays, UV, visible, IR, microwave, radio waves. Right? Now this series is in terms of increasing wavelength, that is from here to here wavelength increases. Cosmic will be having lowest wavelength followed by and so on. So we are moving from lower wavelength towards the higher wavelength from here to here. If we talk about in terms of frequency, then frequency decreases. How? Because wavelength is inversely proportional to the frequencies. So if wavelength is increasing from here to here, then frequency will decrease from here to here. Now if we talk about energy, then energy also decreases from here to here. If you look at this particular formula, E is equals to hc by lambda, then here we can see that E is inversely proportional to wavelength. So if E is inversely proportional to wavelength, so if lambda is increasing from moving left to right, then energy will decrease on moving from left to right. So if we talk about this UV range, in UV range you will see change in electronic energy levels within the molecule. So you will see electronic transitions. We will study the electronic transitions in the UV spectra. If we talk about the IR, so in IR we see changes in vibrational and rotational movements of the molecule. So detection of almost all the functional groups is done in IR. And if we talk about the radio waves, then here we study the NMR spectroscopy, that is nuclear magnetic resonance. Here we see the change in magnetic properties of certain atomic nuclei. So if we look at this overall spectrum, so what we can observe is when small amount of energy is provided, which is sufficient for the NMR spectroscopy, then molecule will show changes in magnetic properties at atomic nuclei level. When more energy is provided and it comes to IR region, then we can see the changes in vibrational and rotational energy levels, that is the molecule starts to vibrate and rotate as well. When we provide more energy, that is it comes in UV range, then what happens, we see change in electronic energy level, that is from one electronic energy level to the other the electron starts to show the transitions. So we see the UV spectrum. So these are all the spectra which we are going to study in the spectroscopy. So we will majorly go for NMR, for IR, UV visible, and we will study a little bit about these micro, X-ray, gamma ray, cosmic ray. We study NMR in separate chapter, IR in separate chapter, UV visible in separate chapter, and in between those chapters we study a little bit about these as well. So this is about overall electromagnetic spectra. So I hope till now everything is clear to you guys, and this video was at least a little bit helpful for all of you. So far that's it for this video. Thank you so much for watching.